Hey everyone, this is Chinmaya, and today we are going to solve problems based on clocks. Well, yes, I'm talking about those clocks that wake you up for your morning exam, and we are going to look at 7 model problems for you to ace your test. Let's have a look at the most common type of questions asked on this topic. To find out the angle between the minute's hand and the hour's hand at a given point of time, to find out what time it is when both the hands are together within a certain hour, or at what time within a certain hour, that is, say 2 o'clock and 3 o'clock, are both the hands of the clock 90 degrees apart or in a straight line which is 180 degrees apart. Or questions that claim that a particular clock loses X minutes or gain Y minutes and ask us to find what the correct time is. And then there are always questions that ask us to find out the gain or the loss of a particular clock. Before we go ahead and solve problems on clocks, I need you to know a few things. The minute hand and the hour hand of a clock coincide once in every hour. And as you guys already know, when the two hands are at right angles, that is the minute's hand and the hour hands, they are 15 minutes apart. And when they are 30 minutes apart, they are in the opposite direction. The hour hand makes a complete rotation, that is 360 degrees, once in every 12 hours, while the minute hand does the same in 60 minutes. This allows the minute hand to gain 55 minutes over the hour hand every hour. Now let's go ahead and solve our first problem. It says, find the angle between the hour hand and the minute hand when the time is 6:20. Well, we solve these problems independently, which means we are going to find out the angle traced by the hour hand and the minute hand and then find out the difference. So we know that the angle traced by the hour hand in 12 hours is 360 degrees. So by direct proportion, the angle traced by the same hour hand in 6 hours and 20 minutes, which is nothing but 6 1 by 3 hours, would be 190 degrees. And the minute hand traces 360 degrees in 60 minutes, but we need to find out what it does in 20 minutes. So by direct proportion, we have again minute hand does 120 degrees in 20 minutes. We then have the answer, that is angle between the hands, by finding out differences of the angles that they have traced, which is 70 degrees. The next question that we have says, at what time between 4 o'clock and 5 o'clock will both the hands of the clock be together? Well, to begin with, at 4 o'clock, the hour's hand is at 4 and the minute's hand is on 12. So basically, the hour's hand and the minute's hand are 20 minutes apart, which means that to be together, the minute hand has to gain 20 minutes on the hour hand. And we know that the minute hand gains 55 minutes on the hour hand in 1 hour. Now, what is the time it takes to gain 20 minutes? Well, we know that by direct proportion, if it takes 60 minutes to gain 55 minute spaces, to gain 20 minute spaces, it would take 60 by 55 into 20, which will give you 512, 511s, 240 by 11, further simplified 11 twos. So between 4 o'clock and 5 o'clock, the hour's hand and the minute's hand will be together. That means they will coincide at 4 hours, 21 9 by 11 minutes or 21 9 by 11 minutes past 4. Our next question says, at what time between 5 o'clock and 6 o'clock will the hands of the clock be at right angles? Now we know that this can happen at 2 times in the same hour. And for the angle between the hands to be 90 degrees, we know that they have to be 15-minute spaces apart. The first case is when the minute hand is 15 minutes behind the hour hand. Well, at 5 o'clock, the minute hand is actually 25 minute spaces behind the hour hand. So, in order to be 15 minute spaces behind, it has to gain 10 minute spaces. So by direct proportion, if the minute hand gains 55 minute spaces in 60 minutes, it would gain 10 minute spaces in 60 by 55 into 10. That is 10 by 11 minutes. So at 10 by 11 minutes past 5 o'clock, the minute hand and the hour hand are at right angles to each other. Now the second case is when the minute hand is 15 minutes ahead of the hour hand. At 5 o'clock, we know that the minute hand is actually 25 minutes behind the hour hand, but this is the case where the minute hand is supposed to be 15 minutes ahead. So, in this case, the gain should be 25 plus 15, which is 40 minute spaces. Again, by direct proportion, if a minute hand gains 55 minute spaces in 60 minutes, it would gain 40 minute spaces in 43 by 11 minutes. Hence, again, for the second time, the two hands would be at right angles to each other at 43 by 11 minutes past 5. For our next question, we have at what time will the hands be in a straight line which is 180 degrees between 9 o'clock and 10 o'clock? We know that the hands of the clock have to be 30 minutes apart when they are to be in a straight line. And at 9 o'clock, the minute hand is already 15 minutes away from the hour hand. So, it has to gain another 15 minute spaces to be 30 minutes apart. So by direct proportion, if 55 minute spaces are gained in 60 minutes, 15 minute spaces are gained in 16 4 by 11 minutes. Hence, at 16 4 by 11 minutes past 9 o'clock, the hands, both the hour hand and the minute hand, are in a straight line that is 180 degrees apart. Now we have come to our gain-loss problems. The question says, the minute hand of the clock overtakes the hour hand in 70 minutes. How much time does the clock lose or gain in 3 days? Well, before we delve in, I need to give you a little bit of concept for this. Now, a minute hand gains 55 minute spaces in 60 minutes. We know this, right? So in order to overtake or meet the hour hand, the minute hand would have to cover 60 minute spaces, which means there is an additional 5 minute spaces to cover up. Well, to find out the time taken to cover these 60 minute spaces, we have by direct proportion, if 60 minutes is taken to cover 55 minute spaces, it takes 65 5 by 11 minutes to cover 60 minute spaces. But instead of doing it in 65 5 by 11 minutes, our clock is taking 70 minutes. And this means that our clock is losing 70 minus 65 5 by 11 minutes, which is 4 6 by 11 minutes every 70 minutes. So now to find out the loss of our clock in 3 whole days, we multiply 4 6 by 11 with 60 minutes an hour into 72 hours in 3 days by 70 minutes, because the loss that is for 70 minutes. That gives us, I am going to use a little bit of calculator, approximately 280 minutes, which is 4 hour 40 minutes. If you could actually put it in fractions, and if you have the multiple choice of fractions, you could do it, but otherwise an approximation will do the job as well. So The loss of the clock in 3 whole days is approximately 4 hours and 40 minutes. The next question on the plate that we have is a clock loses 16 minutes in 24 hours. The clock is set at 6 a.m. today. What will be the correct time when the clock shows 6 p.m. on the third day? First, we calculate the time between 6 a.m. today and 6 p.m. on the third day. Now the duration is 60 hours and we need to understand that this is a slow clock, so the correct time would be much more advanced than just 60 hours. And it has been mentioned that the clock loses 16 minutes in 24 hours, which means that for a right clock that rolls complete 24 hours, our slow clock will move only 23 hours and 44 minutes. Now converting that into fractions, we get for every 24 hours of the right clock, the slow clock moves only 356 by 15 hours. Now we need to calculate for 60 hours of this slow clock, how many hours would a right clock have talked? So, by simple direct proportion, we have for 356 by 15 hours of slow, we have 24 hours of right. So, for 60 hours of slow, we have close to 60.67 hours of right clock, which is roughly 62 by 3 hours. This means a right clock would have moved 40 minutes more and that the time would actually be 6:40 p.m. and not 6 p.m. And the final example that we have is a clock is slow by 5 minutes at 6 a.m. and is 15 minutes fast at 10 p.m. the same day. At what time of the day was the clock showing the right time? Well, to begin with, from 6 a.m. to 10 p.m., the clock has moved for 16 hours. And at 6 a.m., it was 5 minutes slow, which means at some point the clock has gained 5 minutes, and when it has done that, it was the right time. And at 10 p.m., it was actually 15 minutes fast. And in 16 hours, it has actually gained whole 20 minutes. Now by using direct proportion, we simply find out that if the clock has gained 20 minutes in 16 hours, it would gain 5 minutes in just 4 hours. So, 4 hours from 6 a.m., that is at 10 a.m., the clock showed the correct time. Hope you found the video helpful, guys. I thank you very much for watching this video, and if you have an exam coming up, I wish you the very best. Stay blessed. Thank you.